All right, so got your command shaft. That's this. Slots into a little tab on the cross shaft. This is what we call the cross shaft right here. Again, I'll reiterate, if you find that these are twisted, shouldn't be drill bit shaped, that's an indication that you've been slamming into a mechanical stop. And that's exactly what's happening. So you see the full range of movement when you move the actuator one way, you set it up against the mechanical stop, then you back it up just a little bit. Of course, now it's stuck. You back it up just a little bit, so when you're going through your full range of motion on the electrical side, it's not hitting the mechanical stop. So, and then it's the same for both capacity up here and the volume down here. So, okay. I think what we're going to do, let's talk about the shaft seal real quick. So we've got the shaft seal of the compressor if you ever need to change one of these. Very easy to do.
Hey everybody, one more thing I was just informed. Again, I just read off the notes they give me, so please don't shoot the messenger. If you were a presenter.
So, front end of the compressor, main drive motor here, coupling assembly. The front end of the main rotor here, the shaft seal just inside of that. Just quickly talking about shaft seals, be aware that they do leak. They're designed to have a little bit of leak across them at all times. And that's both for the compressor itself and the oil pump. So we get phone calls a lot about a little spot of oil underneath the oil pump under the unit. That's supposed to be that way. You're supposed to have a little bit of oil migration across that. If you're having oil dumping out of the compressor or out of the oil pump, then yeah, you probably have a shaft seal issue. But there should be a little bit of oil coming out of those at all times. We have that bottle on the side of the compressor.
Yeah, so when does it become unacceptable?
It's a range that depends on the temperature of your oil and the pressure. Generally, my rule of thumb is if you're filling that up once a month, you're good. If you're filling it up once a week, then you probably should start looking at a shaft seal change out. So right now I'm pulling the shaft seal housing off. Eventually. There we go. Oh yeah, how'd that get in there? I'm glad you saw that, I've been fighting. All right, that's much easier. So this is the shaft seal housing. In there we have the stationary portion of the shaft seal. When you go to change these out, the shaft seal kit comes with a couple of different things. It comes with the rotating portion that goes on the main rotor. It comes with a stationary portion here that you tap out and replace. It comes with a lip seal here that you also replace, and it comes with this O-ring right here. When you put a shaft seal kit into a compressor, make sure that you get this O-ring in the right groove. It's going to be the one towards the front of the compressor. This other groove is an oil galley, so if you put an O-ring in there, you're not getting oil flow to the shaft seal like you should. So they're pretty easy to change out. With our shaft seal housings, if you guys just want to gather in here real quick, there is one thing. We machine the housing with a little bit of a groove in here to capture that oil. That allows it to go and flow out of the drip tube off the bottom of the shaft seal housing. So that sticks up a little bit. When you tap the stationary portion out, make sure that you don't tap on the lip of the casting. Because you can see right here, somebody did that and broke that away. Typically you're going to want to replace this after that if you do something like that. But that comes out nice and easy. The rotating portion comes out nice and easy. The rotating portion is kept rotating by a nice little roll pin on top of the main rotor here. I'm going to turn it up. If we want to take a look in there real quick, you can see it in there. It's just a tiny little roll pin. When I assemble a shaft seal, what I like to do, you can see that right there. So what I like to do is I like to put a little Sharpie mark on top of the shaft seal by one of these detents. So when you put the shaft seal together, lots of oil, nice and clean, clean everything up, put a bunch of oil in there, slide the shaft seal on there, wheel it back and forth to make sure that you truly have it on that roll pin. I get a phone call a couple of times a year where somebody just sticks it in there willy-nilly, uses the fasteners to pull everything together and shears that pin off inside the compressor. What usually you have to do then is pull the main rotor out of the compressor to get that little section of roll pin out. I've done it myself once where I could get it out with the compressor together, but it's not easy. So again, make sure that you get the roll pin on the detents. Give it a good wiggle. I like to listen for that noise. And then you're good to go. Let's see here. Now I think we're gonna probably pull gate rotor assembly apart. Why don't we do that? Yeah? Okay. So, if we ever needed to change a gate rotor blade, we'll show you how that happens or how that occurs. So, we've got oil lines that are on top of the compressor that feed oil to the bearings here. So pull those off, obviously. Get those out of the way. We've got a row of fasteners on the outside. So on a VSS compressor, there's a row of double fasteners on the large end of the gate rotor support assembly. So we pull the fasteners out of there. And then normally there's going to be an O-ring in here that's going to fight you, so you're going to need the jacking bolts to pull this cover off. Being a training compressor, we don't have those O-rings on here, so that comes right off. Now, I pull this off. One of the things you're going to see here is a shim. This shim is what we use, or these shims actually, are what we use to lift or drop this whole assembly to keep it sitting 0.4 of an inch away from the shelf. And if we step over here, if you look down, right next to the main rotor here, you can see a shelf. So the gate rotor support should be 0.4 of an inch, 3 to 0.4 of an inch away from that shelf. So that shim, or the shim stack that we just pulled off of here, are what we use to adjust that. All right, so next step, we're gonna pull, yeah. All right, normally I wouldn't use an impact wrench when pulling this stuff apart just because it's really easy for some to get broken and get real expensive. But we're lazy today, so here we are. So he pulled off a shoe there basically that bolts the support assembly together. So next thing we're going to do, so we have a toolkit that we sell. There's basically a puller for this bearing housing. Being the training compressor, this all typically comes apart pretty easily, so I'll just lift it out of there like that. So this is the upper bearing, or the large end bearing housing for the gate rotor support. If you need to change these bearings, remove these fasteners, the oil control ring, and then the capture ring, and then they just tap right out, nice and easy. All right, so so it's less important on this side of the compressor because the support assembly is above the shelf. So right here we can see the shelf, and we'll look at this a little closer when we get this farther apart. But typically when we take a compressor apart, or the gate rotor assembly apart, we want this gate rotor support tool in the compressor. And what this does is just keeps the support from falling out of the compressor as we take things apart. Like I said, it's less important here because gravity is pulling the support assembly down into the shelf, and it's just going to sit there. On the other side of the compressor, the shelf is actually above the support, so there's nothing holding it up. So when you take the bearing housings off, gravity is going to try and pull that support out of the main rotor, and you end up damaging blades that way. So that's why we have the support assembly. And it sits in there like this. I don't know if you want to just swing back and take a peek at it or not. All right, so we have the upper bearing housing, or the big end bearing housing off. Now we're going to pull the roller bearing assembly. You want to grab that? All right. My lovely assistant Ryan will. Those are all loose. Yeah. Oh yeah, those will be 9/16. So this is going to want to fall right out of there. There's an O-ring that holds us in there, but if that O-ring were to break loose, it just takes off. So just be prepared for that. I like to hold on to it. On the other side of the compressor, if I'm pulling, you got it? Okay. So he's going to pull that out of there. On the other side of the compressor where the big cover is, there's a lot of weight there. I like to stick some all thread with some big washers there to capture it as it kind of drops down. Because it's oily and tends to be pretty slippery. So this is a roller bearing assembly in there. So if you're going to change bearings, like I said, so on this portion of it, that bolt circle comes off, the oil control ring comes off, and you tap your bearings out. Here, you need a snap ring pliers, and you need a bearing puller basically to get that out. You're going to end up wrecking these as you pull them apart because it's just there's no good way to grab them, unfortunately. All right, so at this moment, here's our gate rotor assembly. If we wanted to change the blade, we need snap ring pliers that I don't think I have with me because I accidentally gave them away at the last site I was at. Snap ring comes off. The washer, the support washer comes off, and then the blade just pops right off that way. Nice and easy. So now that we've got this out of here, let's take a look inside the compressor. Yeah, why don't you move that out of the way a little bit. This is the shelf that I was talking about. So this is what we want to space that gate rotor blade away from just slightly by 3 to 4 thousandths of an inch. So if you have this out of there, you can take a good look at the inside of the compressor. All hands and fingers clear. Spin the main rotor. I like looking at all the flutes, making sure there's no damage to anything. You can definitely see the back end of the slide valves here. Get a good look at them to make sure there isn't too much wear. So everything looks nice and good. At this point, we'd essentially have the blade changed and start throwing stuff back in the compressor. All right, a couple of things to talk about. So you saw me kind of move the main rotor a little bit when I was pulling the support out. It's because if you have the main rotor in the wrong position, the blade doesn't release itself from the flutes of the main rotor. So what I like to do is I like to look at the, I'll show you here. I'm looking at right here, the front end of the main rotor. I want about a 3/4 of an inch to an inch of tooth, roughly, sticking above the shelf here. So this is the shelf. I want a little bit of tooth sticking above that. And that's the main rotor in the position that it should be to be able to easily remove that blade. I've taken a compressor apart where it locked up in the wrong position. You end up having to chisel the blade apart to get everything out of the compressor. It's no fun.
Should you be replacing those blades as a set?
It depends. I would say measure them. You know, it really depends on, you know, do you want to spend that money all at once? That's great, yeah.
You got it apart.
Yeah, true. It's blown down, you've got it apart. To my mind, I would, but you know, it's not my money that not my budget that I'm trying to work with. So, you know, if you got one side that measures good and one side that measures bad, you know, it's up to you. Truthfully, it doesn't really affect the compressor if you have one new blade and one bad blade, or one old blade, not bad blade, one old blade. The blades themselves should be good for the life of the compressor. They're not considered a wear item, even though they do wear slightly. If you are wearing out blades, chipping blades, breaking blades, it's typically a system issue that's causing that. Again, look for wear in the OD of the blade itself, chipping, whole sections blown out because of liquid slugging, stuff like that. When you diagnose a compressor, so if you have like one bad bearing here and there's no bad bearings anywhere else, yeah, that may be an assembly error or a material issue. If you have all sorts of bad bearings within the compressor, that's usually an indication of a system fault that's causing that. And again, these bearings, they're widely oversized for their use. Their calculated life is almost infinite, so you really shouldn't be wearing bearings out. If you are, again, that could be a good indication that there's a system issue. Either your oil viscosity is wrong, you've got too much dirt floating around, you've got moisture in the oil or something like that. So, what else? What else should we talk about? Any questions as we're standing here?
Well, you had mentioned the life of the compressor. What is the anticipated life?
A long time. So I've got a gate rotor blade sitting on my desk that's got 100,000 hours on it. I was talking to somebody here who has 70,000 hours on a machine they've never opened. So they should live a good long time if you're treating them correctly.
To put into point, the main areas, guaranteed for 150,000 hours. So approximately 15 years of continuous service.
Yeah, that's one of the interesting things. You know, we have a 15-year bearing warranty on the compressor, subject to consideration. We expect them to last longer than that too. So, I don't know what else. Like I said, any questions right now?
Gate rotor,
You got some good questions. Gate rotor what?
gate rotor inspections yearly, right? Recommended gate rotor inspections.
Yeah, yeah. So we have a chart, both in the microprocessor and in our manuals, that gives you a list of, when you should be looking at things. Yearly is not a bad time to do it, really. It's roughly 8,400 hours in a year. That's probably a good time to start looking at stuff. Actually, now that we've got this out, we can easily see what we're measuring. This is when we do the one check of the damper pin, damper bushing. This is what we're measuring right there. We don't want to make we want to make sure that that's not coming out from underneath and able to contact the main rotor. You can hear it when it starts happening, because when you shut down or start up, it'll make a grrr noise for just a little bit, and then usually that's new compressor time at that moment.